What's up, YouTube? Today we are going to go on LeetCode and try a random easy question, particularly one of the easy algorithms that I have not solved yet. We're going to choose this at random and just see how it goes. Okay, this problem is called minimum subsequence in non-increasing order. Interesting. Let's see. Given the array nums, obtain a subsequence of the array whose sum of elements is strictly greater than the sum of the non-included elements in such subsequence. Wow, that is a mouthful. Okay. If there are multiple solutions, return the subsequence with minimum size. And if there still exists multiple solutions, return the subsequence with the maximum total sum of all elements. Okay, let's see. We are going to be doing this in Python. I'm a Python dev. Okay. For problems that are just this abstract, this many moving parts, it's really important to take a look at some of the examples and to kind of start to do some pattern recognition here. So the first example with the input of nums is an array with 4, 3, 10, 9, 8. Okay, that makes sense. Our input here, we've got a parameter called nums, which is a list of integers, and it's going to return a list of integers. Okay. And the output is a list with 10, 9. Okay, the explanation. The subsequences 10, 9 and 10, 8 are minimal, such that the sum of their elements, which is going to be 19 and 18, is strictly greater than the sum of elements not included. Okay, so let's see here. 10 plus 9 is 19, which means 4, 3, and 8 are left out. 4 plus 3 is 7. 7 plus 8 is 15. That's right. 19 is greater than 15. And then 10, 8. Okay, 18 is still greater than 16. Okay, so that is correct. Okay. However, the subsequence 10, 9 has the maximum total sum of its elements. That's right. So if we've got two possible answers, the list with the greatest sum, maximum total sum, is the correct answer. If there are multiple solutions, return the subsequence with minimum size. The minimum size. Okay. Okay, subsequence, non-increasing order. This non-increasing order is actually confusing me more than it is helping me. What does it mean by non-increasing order? Note that the solution with the given constraints is guaranteed to be unique. Great. Also return the answer sorted in non-increasing order. Okay, so that's where it comes in. Never mind, that makes sense then. Okay, subsequence. Let's talk about the meaning of these words here. A subsequence. Okay, so a sequence is like a linear array, or not an array, like a linear collection of elements. So you could have a subsequence problem involving a string. It's a linear data structure. A list, certainly a linear data structure. You're not going to see a subsequence problem for something like a dictionary, or say a hash set, or like a binary tree or graph or something. Probably not. I'd actually have to think about that for a little bit here. How are we doing on time, by the way? I have no clue. All right. Oh, 4 minutes and 50 seconds. Okay. So let's take a look at example number 2 and see if we can figure it out here. Input is nums. Okay, so these numbers don't appear in any sort of order. These are clearly unordered. 44767. Okay, this is interesting because obtain the subsequence. Okay, I was talking about what a subsequence is. A subsequence is part of the larger sequence, so like a set of the larger sequence, but you can drop any of the elements. So for example, 4108 is a subsequence of this input list. Same with 398, 1098, right? 4310. Okay. Or just 4. Technically, that is a subsequence of this list as well. 48 is a subsequence. But it does need to maintain its order, even though you can remove any of the elements. Okay. Notice here that the subsequence 767, okay, let's see here. The subsequence 77 is equal to 14, which is not greater than the elements not included, right? 7 plus 7 is 14. 4 plus 4 plus 6 is also 14. Hence, the subsequent 77 is not greater. It is equal. Therefore, the subsequence 767 is the minimal satisfying condition. Note that it's increasing, non-increasing order. Okay, so that's an annoying way of just saying descending order. So even though the subsequence is 767, the output is 776. So it's sorted in reverse. I was just seeing how many people are talking about this, how many thumbs up or just comments this question has. Okay, so if this were a technical interview and you received this problem domain, first thing you'd want to do is ask questions, ask clarifying questions. Clarify the meaning of subsequence. Clarify some of the constraints of your inputs here. For example, nums, this input list, will have at least one element. Okay, so you would always, generally speaking, ask, what if nums is empty? What if your input is empty? That's almost always a good question. Then if you know that you're dealing with, say, a data structure of integers, you could ask about maybe it matters if any of them can be negative or not. In this case, we're talking about sums. And if you add a negative number to a positive number, right, that's not going to be any bigger. It's going to be smaller, subtraction effectively. And knowing that each one of the elements inside of the input list is a positive number, maybe could, help out or be something to consider. Okay. So we could clarify some of those constraints. What other kind of clarifying questions might I have here? I think would probably want to ask about some of the edge cases. What would edge cases be here? Not negative, not empty. Okay, so how about an array or in Python? So a list with just one number inside of it. Okay, if it only has a length of 1, then is the output always going to be the same as the input? Okay. let's see. There aren't any elements that aren't included. Because if it's got a list, let's see if I can take a note here. How do I take a note? Okay. If I have a, say for example, input with just a list of 1, is my output also going to be 1? Not an output is 0, I guess. There aren't any elements. Okay. So we'll just kind of keep that in mind there. Let's see here. Let's make a new test case, and we're just going to give this an input with just one number. And we're going to just return a wrong answer here. I just want to know what this expects. Okay, so it is expecting the list with just 1. Okay, so output is also 1. List with 1 inside of it. Great. So that is an edge case where the list just has 1 element, then it's just going to return itself. So at the very least, we can have kind of like a guard clause here, an early return. The length of nums is equal to 1, just return nums. There's no sorting, we don't have to do anything else. When the input is the same as the output. Okay. Let's also see here. After you ask and answer some test questions, clarifying questions, I spoke a little bit too soon there. We're going to start asking about and creating test cases. So I already created my own test case with just a list with 1 number inside of it. Let's see here. So then it's got 2 elements, then it's going to be the larger of the elements because, okay, what if they're both equal? Then that's still going to return, okay, just one of the elements. So this would also return a list with just 1 inside of it. These are both equal. Let's confirm that. No. Expected 1, 1. Okay, what did we get wrong there? So the number 1 is a subsequence. It is not greater. Okay, that's it. It's equal to the other elements. It's not greater. Okay, so it just returns. The input is also equal to the output in this test case. Let's create another test case, and I'm just going to kind of continue down this thread. I just need to figure out what the boundaries are here. So if it's a list with 3 1s inside of it, 3 elements, all of them are 1s. Now I expect the exact same output as case 4. A list with just 2 1s inside of it. 1 plus 1 is 2. 2 is greater than 1. No sorting that needs to happen. And it expected, okay, list with 1, 1. Okay, perfect. Okay. Let's come up with some more, how about like more interesting test cases than just a list with ones inside of it. So we already know what happens when one of the subsequences is equal. In this case, or in this problem, subsequence basically just means any combination of elements. Regardless of their place. So, like, if one of the elements just blows every other element out of the water, this case 6 is going to return 100. The output should be 100, a list with 100 inside of it. Okay, good. And if it's 10, let's go back to this test case. The subsequence 1010 is, okay, it is not greater than 9 plus 8 plus 3. It is equal to 9 plus 8 plus 3. So why would the inclusion of any other element would make it larger than the other two? What part of the rule would say this? Okay, so my theory is that this input should the output should be 10, 10, 9. Let's just confirm that really quickly. 10, 10, 9, great. Okay, here's the question I would have for the interviewer. 10, 10, 9 is obviously greater than 3 plus 8. 10 plus 10 plus 9 is 29. 3 plus 8 is 11. 29 is greater than 11. So we have solved our problem of one of the subsequences sums being equal to the sums of the other elements by including another element. What is the rule that requires it to be the largest element of the remainder? Because 10 plus 3 plus 10 is 23. That's 23 is still larger than 17. We can include the 8, and they would still be larger than 3 plus 9. 28 is greater than 12. So let's double check what the rules are here. If there are multiple solutions, minimum size. Okay, so the minimum size, that's a good clarifying question, is the meaning of size. Context clues here would suggest that size would refer to length of output. So the length is what they mean by size here. So the smallest, okay. And if there still exists multiple solutions, return the subsequent. Okay. That's why you have to choose 9, because 29 is greater than 28, 10, 10, 8. It's also greater than 23, 10, 10, 3. Okay. But all of them have a length of 3. Okay. So that's what's going to solve it. And then it needs to be sorted. So just to confirm, let's swap these elements around. Make the first element 8 and the last element 10. And in this case, the output should be the same. 10 plus 10 plus 9, or 10, 10, 9. 10, 10, 9. Okay, very good. Okay. So this is, I don't know how challenging of a problem this is to solve yet, but understanding the problem is certainly challenging. It's taken me almost 20 minutes just to kind of wrap my head around here. But I think I understand the boundaries here. in general, when you are solving a technical whiteboard problem, a LeetCode problem, data structures and algorithms, you need to understand the problem before you can even start to begin working on the solution. And then you want to solve the problem, at least visually or algorithmically, before you code out the solution. So you got to understand the problem. That's where reading the problem domain, asking clarifying questions, experimenting with the different test cases to find, what are those edge cases? What are the boundaries of the problems? What makes the problem difficult? If you're in a interview and the problem just feels too easy, I would ask myself, or you should ask yourself, is there something I'm not getting about this problem? Is there something that makes it trickier than it actually appears on its surface? Oftentimes there is, and oftentimes it is your job as the interviewee to figure out what makes a problem difficult. And then, of course, take that into consideration in your solution. Okay, so I need to find the shortest combination of elements that when added together are their sum is greater than the remainder here. And what kind of problem is this? This is like an optimization problem. Probably could be solved with dynamic programming. Let me think about that. So I know I need to traverse the input list nums. And then as I see each element, I see each new element. I would know that's a tough question. As I traverse the list, I would need to know the greatest subsequence or the minimum subsequence in non-increasing order so far. And okay. Actually, no, dynamic programming could work. That'd be like a two-dimensional dynamic programming problem where you could represent this as a matrix of sorry, the neighbor's dog is barking like crazy right now. It's distracting me. You're keeping track of not only the subsequence, the minimum subsequence in non-increasing order so far, but also keeping track of the sum of the elements not side of it. So it kind of end up looking like a triangle. That seems unnecessarily difficult. Knowing that we also need a maximum total sum of elements here, I think the first logical step is I actually just want to sort the list. Okay. So let's take our case number 6 here as an example. We're going to go on our note, and our input is going to be this list. Our output is going to be the list of 10, 10, 9. Yeah. So how do we get from the input to the output here? Okay, so if we're going to, no, I don't want that much. If we're going to sort the input, we go 10, 10, 9, 8, 3. Once we sort, okay, we can add up numbers along the way and find the point where the first instance where the first half of the list, its sum is greater than the second half. Okay, so we start 10 is not greater than the sum of 10 plus 9 plus 8 plus 3. That's going to be 8 plus 3 is 11 plus 9 is 20, so that's 30. 10 is not greater than 30. 20 is not greater than 20, but 29 is greater than 11. Okay. So once we sort it, we need to do we do this with one pointer? If we do this with one pointer, I think this is a 2-pointer problem. If we do it with one pointer, problem with doing it with one pointer is that we're constantly recalculating the sum of the remaining elements in the sorted list. And that is just really inefficient. That turns it, I mean, sorting is already O of n log n. And doing it with one pointer is going to turn it into O of n squared. So it's O of n plus O of n log n plus O of n squared. That sounds terrible. We did it with one pointer or 2 pointers. That would be O of 2n, which simplifies to O of n. Or after it's sorted. Okay, so it would simplify back to n log n. So that would be more efficient than using one pointer. Okay, so how would 2 pointers work? Basically, that means we're going to have a pointer that starts at the very first element. We're going to have a pointer that starts at the very last element. And we are going to two-pointer traversal. We're going to need to have logic for moving the pointers. We move eventually. We have 10 and 3. We have 20 and 11. 20 and 20. Okay, so if the... Okay. We're also going to need to have... we're going to need to keep track of sums. Okay, so sum like a running total basically. Okay, so I'm gonna call this output counter and initialize it to be 0. Then I'm going to have, yeah, remaining elements counter. So is also going to initialize to be initialized to 0. So this is our first pointer. So first pointer traversal, 0 turns into 10, 0 turns into 3. 10 is greater than 3. Okay, 10 is greater than 3. So we move the trailing pointer. Okay, got it. Got it. So, okay, here's our logic. If the output counter is greater than remaining counter, move the pointer for remaining. Okay, move the pointer, move the trailing. All right. I should label these. This is going to be pointer I, because we love our variable names I and J. This is going to be pointer J. Let's just do that in its own line like this. Okay. So if output counter is greater than remaining counter, move J. J minus equal 1. Okay. If output counter is not greater than the remaining counter, so we're going to say else. Do this with a colon. Else, it's not greater, so it is either going to be smaller than or equal to. In that case, we need to move the move I, which is going to be I plus equals 1. Increment I to move the pointer to the right, decrement J to move the pointer to the left. How are we doing on time? 33 minutes. Okay. Try to do these under 45 minutes in total. So if 45 minutes is the goal, then I'm coming up on maybe 11 minutes left here. Okay, so this is taking too much time. I'm a little bit slow today. Okay. And basically we are going to traverse until I equals J. And then we're done with our traversal. How do we know what to output? Well, basically, by the time I equals J, so let's see here. Oh, I forgot to mention how we're going to update output counter and remaining counter. At the beginning, move. Okay, move. And okay, so we move J and reassign remaining counter. And then continue iteration. Just move this here. else we move I and reassign output counter. And then continue iteration, and then we continue until I strictly equals j. Okay, so what's this going to look like for our input array? Starting off, I and j are going to be 10 and 3. Let's make new variables for I and j. I is going to initialize to be 0, which is going to be the start of the list. I will continually you say list and array, they're synonymous, mostly because the description talked about an array, and in Python, of course, it's called a list. So I'll try to say list here. J is going to initialize to be length of nums minus 1. That's going to be the index of the last element in the list, in the input list. So J is going to start at the end here. So output counter, actually that's right. We don't want to initialize these to be 0. We want to initialize them to be the first element and last element respectively, okay? And we know at the very least, I is either going to be greater than, the first element 10 at index I is going to be greater than or equal to the last element in the list, which would happen if it is a list and they're all the same number because we've already sorted here. Okay, so let's actually move these and change what we initialize our lists to be. So output counter doesn't start at 0. Output counter starts at nums at I, which is 10. Okay, so we assign 10 to output counter, nums at j, we assign 3 to the remaining counter. Okay, great. So 2-point traversal. We're going to do this in a while loop. While I is not equal to j. No, eventually they're going to match. Right? Okay, this is either not equal to or less than or equal to. No, while j is greater than or equal to I. While j is greater than or equal to I. How would that work? Basically, it means, or you could do I is less than or equal to j. That's actually, I like that better. That makes more sense in my mind. Well, I is less than or equal to j. That means it will still traverse when I and j are equal. That's not going to work because that would assume the same element is part of the output counter and remaining counter. Okay, so that's not going to work. Well, I is not equal to j. When the streams cross, we stop traversing. While I is not equal to j, and this is what we're going to do. I'm just checking the timer. 39 minutes. Okay. Go over 45. I'm still going to record, but in my own mind, personally, I'm going to mark this down as a failure. Failure for running out of time. Okay. And this is going to be our logic. by the time we get to the end, we can use slice notation. I is going to be right next to j, so the eventually it's going to look like I is 9 and j is 8, right? Let's just double check that. So I starts at the first element, 10, j starts at 3, 10 and 3. 10 is greater than 3. This is more of a step through that I'd do at the very end. I'm going to do this right now just to make sure I'm doing this correctly. J, okay, so output is 10 is greater than 3. We move J to 8. 3 turns into 11. 10 is not greater than 11, so we move I. 20 is greater than 11. Let's just show how this the state of output counter is changing. So 10 turns into 20. 20 is greater than 11. J moves up to 9. No, yeah, 20 is greater than 11. J moves up to 9, and it's 20. Okay. Oh, this isn't going to work. If it's equal, we still need to move I. Okay, so I is not equal to J. Wait a second. No, nope, still on the right track. I is not equal to J. Output counter is not greater, because 20 is not greater than 20. Okay, so we move, okay, we're in our else statement. We need to move I, and then reassign. Okay, great. No, but I would have been equal to J. That moves I right here, just to mark that they're both at 9. And then what? The output counter becomes 29. I mean, that would still return the correct answer, but for the wrong reasons. I think it's fine that the remaining counter, 9 is double counted here, because 29 is still greater than 20. And it always will be. Yeah, because it's going to be sorted. So even if it were 10, it would be, yeah. Okay, we're going to have to double check here. Especially for lack of time. All right, it's 44 minutes, marking this one down as a failure for not doing this under 45 minutes. Okay, let's finish up the code here, and we'll go through the walkthrough. We'll run our test cases and make sure we're doing this correctly. Okay. So moving over to code, we've got our guard clause. Let me just label this with a comment. Guard clause. We need to sort the input list in decreasing order. So we're going to say nums is equal to sorted nums. Always forget how to do this. List.sort, that modifies the list in place. Usually is less convenient than sorted. Yep, sorted any iterable. Reverse sort. Okay. Except a reverse. Okay, cool. Reverse equals true. Oh, okay. Learned something new today. There is a second optional parameter here. Reverse equals true. Actually, I like nums.sort better. Nums.sort. Nums.sort reverse equals false. Okay, key equals none. Great. So let's do, this is reverse equals true. Okay. Reverse equals true. Great. Sort the input list in descending order in place. This does not have a return, just sorts the input list. Okay. Input list is sorted in descending order. Now we need to define our variables. We're going to say I equals 0, j equals the length of nums minus 1. We've got output counter. We've got remaining counter. It's at j. Okay. So it starts with the first element. Output counter starts at the first element. Remaining counter starts at the last element. Okay, now we need to traverse. While I is not equal to j, remember I and j are just numbers that represent indices inside of our sorted list. So these are indices. While I is not equal to j, now we are going to check our output counter and remaining counter and have some conditional logic here. If output counter, I wish they had autocomplete here in LeetCode. If output counter is greater than remaining counter, then we need to move j, decrement j, and then reassign the remaining counter. Okay, so remaining counter. I should have been more clear here. We are going to increment remaining counter by the jth element, the new jth element. Remaining counter plus equals nums at j. Okay. Else it is equal to or less than. So we need to move I. I is going to be plus equal to 1. And then we need to increment output counter. Output counter plus equal nums at the new I. Okay. Excellent. So what's the point of all of this traversal, keeping track of the output counter, remaining counter? Well, what's super important at the very end is that I is always going to be at the last element inside of our output subsequence. So in essence, we can just return and use slice notation here. We can do nums, and it's going to start at the first element of nums and go until is it inclusive? It might be I plus 1. I need to double check. This list. Negative indices, and yeah, so the end is end included. I don't think it's included. Where is end? From initial to index end. We're just gonna have to run it, see if this works. So basically up to and including I. Okay, and that's going to be our output here. Let's run this. If output counter is greater than remaining counter. What did I do here? Invalid syntax. Oh. I forgot the colon here. Nope, that doesn't make sense. If output counter is greater than remaining. Oh, I missed an underline. Okay. The colon, of course, is at the end. Wrong answer. Okay, cool. Let's see what we've got. 10, 9. Okay. So we're missing the last one. We're missing the last one. So I do need to add 1. I plus 1. God, that just looks gross. I hate how that looks. Okay, but everything's working. Okay. Why did we need to add 1 to I? It's because the slice, I was right. It is not including the ith element. So if by having nothing in front of the colon at the beginning, it's implicitly a 0, which means we start and include the first element, but go until and not include what comes to the right of the colon. We could have a second colon in here, which is going to be step. This is a lot like a JavaScript array where it's like start, stop, step. Kind of how I think of it. This is implicitly included. So this would also work. The step is 1 by default, and the beginning is 0 by default. So to make it cleaner, I deleted too much there. Let's try this again. To make it cleaner, we can remove the second colon here. That's actually another cool way to do sort. I could have done sort with the slice notation as well, where it's nums bracket colon colon -1 from the beginning to the end, but in negative step. So basically each step goes from the end all the way to the beginning, and that would reverse the list. So I could have sorted and reversed the list that way. Okay. But this looks clean. Let me just make sure I haven't ruined anything here. Okay, and we're going to submit. And we are accepted. Great. Okay, let's take a look. Let's analyze our solution here. Got 54 minutes. Okay, normally I'd like to spend more time analyzing the solution, figuring out what I could have done better, and you know, just kind of time for learning, time for reflection here. I want to keep the videos, at least for these LeetCode challenges, under an hour or right around the hour mark. So I'll kind of speed through this one. Obviously, not obviously, to me, what is obvious is that figuring out what the problem was the challenge. Okay. Just wrapping my head around what the problem was actually asking me to do. On first read through, I was like, I didn't say this, but in my mind, I was like, how is this an easy problem? Like, this sounds really difficult. Frequently, subsequences come up in very difficult and very interesting problems here. And there's all these rules about maximum total sum, minimum size, making sure they're non-increasing order. Okay. um Actually, these constraints, returning the answer in a non-increasing order, this made it easier. Returning the subsequence with the maximum total sum as a tiebreaker, that made it easier. And the reason it made it easier is because once I sorted the input list in reverse order, everything kind of fell into place. All of those constraints actually made solving the problem a lot easier. If I needed to preserve the original subsequence order, or if I needed to say, you know, take the minimum instead of the maximum sum, which would mean all my answers, the tiebreaker would be taking the minimum number here, okay? That would actually make things a lot harder for me. And I would need to figure out, okay, I need to figure out a way to unscramble the eggs in order to output the correct answer. So this ended up making it a lot easier once I got into solving the problem, but it did also make it much more challenging to just wrap my head around what was I supposed to do. And you notice I made a lot of test cases here. In LeetCode, that is absolutely a great strategy where you can come up with your own kind of hypotheses, test cases, and check your work, because when you run, you will get test results that indicate what the correct answer should be. And that is a source of truth. Being able to come up with these test cases is fantastic. Pardon me. Okay, so it took me about 20 minutes just to figure out what was going on in here. So I could have, what could I have done differently? I'm checking time, almost done there. I think the biggest thing I could have done differently is just take a few minutes at the very beginning to really closely read these 3 paragraphs. And that's not super common, where you're going to have a quote unquote easy question that requires 3 paragraphs and a whole bunch of rules to convey the problem domain. This is a very heavy problem domain. It's kind of sucked for a very first challenge here, but in an interesting way. I think I learned a lot. Okay, so really taking the time to just read it and consider it more would have saved me more time in the long run. I Part of the challenge of speaking your thoughts out loud and doing this in front of a person, or in this case in front of a camera, is that there's like this pressure to keep saying stuff, and keep saying intelligent stuff that is going to get you the job or to solve the problem or to show that you're smart, whatever. It's a social interaction and you want to fill the silence. It is often worthwhile to take literally a minute or two if you need to think through something, especially if you're more introverted or talking and typing at the same time is especially challenging for you. Taking the time to actually think and telling the interviewer, hey, I'm going to think about this for a second, so that it's not an awkward pause, it's a thoughtful pause. Eventually, though, you're going to have to say something, right? So you're going to have to think quickly here. Wrapping my head around the problem, that took quite a long time. Realizing that I needed to sort and reverse, that made things a whole lot easier. And if you've never seen a solution like this before, wherein doing some sort of, how do I describe this? Some sort of preparatory step, some sort of intermediate step that like helps the whole process, makes everything click into place a lot easier. Um, this is a great example of this. Sorting and reversing the input list made doing everything else way easier. Okay, if I had not sorted and reversed, by the way, check with your interviewer if you're allowed to use the built-in sort method or any built-in method. In this case, I would assume it would probably be okay because it would be much more challenging for me to write my own sorting algorithm. Absolutely doable, um, but would really expand the scope of what this problem is asking here. But that sort of prep step of converting my input, I haven't solved the problem yet, but I've taken a step to make solving the problem much more easier. Um, that is always something to think about. For example, there's plenty of problems I can think of that are linked list problems where reversing the linked list makes everything so much easier because the question asks you to start modifying nodes in a conditional formatting way that are at the very end of the list. So you initially, if you don't reverse it, you're going to the very end and then you're keeping track of what happens and you're going towards the beginning. It becomes this kind of recursive mess. Just reversing it as an intermediate preparatory step makes things a lot easier. In this case, knowing that these could be in any order and in fact needed to be in sorted in non-increasing order anyways as the output, made me realize, okay, this is the step I need to take. This is going to make my life a heck of a lot easier. If I couldn't do that, or if they weren't going to be sorted, I would absolutely need to do some sort of multi-dimensional dynamic programming, keeping track, or else things would just the big O of time complexity would just be way too crazy and inefficient here. Okay, wrapping things up here, definitely going over an hour. What's the rest of this? Okay, the rest of this is just classic two-pointer algorithm, starting at the very beginning, and the very end, and moving incrementally towards the middle. Here's the important part when you're doing a two-pointer solution: figuring out where your pointers start. Sometimes both pointers are going to start at the very beginning, and you're going to have like a lagging pointer. Okay. At this case, the pointers go at the very end. So you're always thinking about what are the conditions for moving each pointer. Okay, under what conditions? To me, or in this case, moving j means decrementing j by 1, and moving I means incrementing I by 1. But there are very specific circumstances, and the logic is figuring out, okay, when do I move j and when do I move I? I'm looking at my output counter and remaining counter. So I'm thinking that, okay, I know eventually I need the smallest output counter possible. Smallest size in this case meaning length means, okay, I need to move j unless it is time to move I. But where was the case where, oh, I thought I had a case. I must have changed it. Say, for example, in case 6, this beginning 8 were like 100 or 1,000. We know that the output is just going to be a list with one element, and it's that 100 or 1000. It's clearly bigger than the rest of the elements combined or summed up. But that's a very obvious scenario where we know intuitively that I is never going to change. It's going to stay at 0. And we're only moving j up until the point where they equal each other, because we need to figure out, okay, well, are is the sum of the rest of the numbers elements in that list, is it actually less than that first element? So we keep moving until it's not, and then that tiebreaker means the tiebreaker is if it's less than or equal to. We do the else statement here. So the tiebreaker means we move I. It's going to take the next greatest element, and then when they match, we exit. So 2-pointer. Logic for moving the pointers. Logic to stop traversing. That's the important part here. What's your logic? And then what do you do at each step? Okay, in this case, I am either incrementing remaining counter or incrementing output counter, which are very closely tied to I and J. I and J being kind of like the index of what you have summed so far. Okay, and then at the very end, no cleanup steps are necessary. Sometimes you need to do an extra one-off kind of step after you traverse your input. In this case, the entire point of traversal wasn't to actually get the sum of any sub list or subarray here. But so it's not the important part isn't that I'm returning 29. It's that I'm returning this part of the sorted list. So Python, I'm just using slice notation. And then you saw me work through needing to add 1 to I to make sure that I get the correct, slice, the correct slice, because I do want to include the ith element. So I feel like that's, and it looks inelegant, but it totally works. Okay. Anything else? We have gone well over an hour now, hour and 7 minutes. What else could I have done? I could have done I did a little bit of a step through. That could have been more visual. Big O. Ooh, I didn't analyze O of the space complexity, and notice that in terms of how it ranks against other LeetCode submissions, this took up quite a bit of space. Let's do that really quickly. This is O of 1 space. Sorting in place. It's not reassigning, so that actually isn't any. This is not any additional amount of space. Nums is already included. O of 1, O of 1, O of 1. These are all just integers that get incremented. Okay, and then I'm returning a slice. So it's O of n because we're sorting. Actually, let's double check here. I think it's O of n because we're sorting this input list in place. That could actually cause some issues if the list that is given to our function, because it is mutable, we are actually changing it. Okay, so that could be concerning. It won't affect the solution here, but knowing that nums is a list, we're changing it, that could actually cause some bugs down the road. Let's get some space complex. Yeah, O of n. Okay. So everything else is O of 1, but reversing this list in place is O of n. Okay, that makes sense. Because it's taking up space in memory equal to the size of the input array. Okay, and then runtime should be O of n log n because we're sorting. That's the most complex thing we're doing here. Everything else traversing this list would be O of n. All these comparisons is O of n. Looking up the element in a list is O of n. Incrementing is O of n. Slicing, yep, O of n. So this should also be O of n. Sorry, n log n for the sorting algorithm. Yeah, and that's going to be truly the thing that makes this algorithm most complex, or space complexity, is the fact that you have to sort, that I'm sorting this list. Could there be a more efficient solution that doesn't sort and goes in a single pass? Yes, it would be probably some sort of dynamic programming, like a two-dimensional list representing the running solution. Man, I didn't describe that properly. The sub-problem that is being solved as you traverse it. Could there be any other way to do this O of n without sorting? Yeah, some sort of dynamic programming way. Okay, that's going to wrap it up for today. I'm going to keep recording these and keep on practicing. If you have any questions about this problem or any comments, particularly for how much I stumbled on this one, go ahead and leave them in the comments section and I'll try to take a look at them and respond to you. In any case, have a great day.